Students, colligative properties are one of the most important topics in second PC chemistry from the chapter solutions. It is belongs to physical chemistry. From these four colligative properties, you will get at least two numericals in the final exam. Each numerical is for 3 marks. So if you learn these four colligative properties, you can easily score 6 marks in the final exam. So theoretical part also you remember, colligative properties are the properties depends only on the number of solute particles present in the solution but not on their nature. So these properties values depends on the number of solute, not on the nature. Whether it is ionic, covalent, it is not going to depend on the nature, but depends on the number, how many moles of solute you are going to dissolve. Those values, colligative properties values, depends on the number of solute particles. So there are four colligative properties. First one is relative lowering of vapor pressure, second elevation in boiling point, third depression in freezing point, and fourth is osmotic pressure. So let us know the meaning of relative lowering of vapor pressure. So first of all, you remember vapor pressure of pure solvent is represented by P naught A. P naught A is a vapor pressure of pure solvent. For example, vapor pressure of pure water is 23 mm of Hg. When you add any non-volatile solute, for example salt or sugar, into the water, when you add a non-volatile solute into the pure solvent, the vapor pressure is going to decrease. That is what lowering of vapor pressure. Lowering of vapor pressure after dissolving non-volatile solute in solvent, vapor pressure is going to decrease. Now vapor pressure of solution after adding non-volatile solute, vapor pressure of solution we can write it as Pa. For example, when you dissolve 1 gram of salt in water, vapor pressure is decreased from 23 to 22 mmHg. Say for example. Now children, lowering of vapor pressure is can be written as P naught A minus Pa, where P naught A is a vapor pressure of pure solvent, for example 23, and Pa is vapor pressure of solution after adding non-volatile solute, say for example 22. And relative lowering of vapor pressure can be written as the ratio of P naught A minus Pa divided by P naught A. So this is the formula of relative lowering of vapor pressure, and this relative lowering of vapor pressure value depends on how many mole fraction of solute you have dissolved. So relative lowering of vapor pressure is equal to mole fraction of solute Xb. Relative lowering of vapor pressure is equal to mole fraction of solute Xb. Now we know the formula to calculate Xb. Mole fraction of solute can be solved by the formula NB, number of moles of solute, divided by sum of the number of moles of solvent plus number of moles of solute. N is number of mole, A is solvent, B is solute. A is representation of solvent, B is the representation of solute. So students, for a dilute solution, number of moles of solute is very less when compared to number of moles of solvent. So in the denominator we can neglect number of moles of solute. So we will get relative lowering of vapor pressure is equal to NB by NA. NB divided by NA. This we know. Now we also know that number of moles of solute or solvent can be calculated with the formula mass by molar mass. Number of moles can be solved by the formula W is mass divided by M. M is molar mass. So in place of NB, we can write mass of solute by molar mass of solute. In place of Na, we can write mass of solvent by molar mass of solvent. This we can write. Now we will do the cross multiplication to this value. When we do cross multiplication, we will get WB into MA, that we can write here WB into MA divided by here WA into MB, WA into MB, here WA into MA. mb. Now from this formula we need to calculate molar mass of solute. So molar mass of solute we can calculate by if you take molar mass of solute this side, so along with wb and ma you need to take this p naught a, vapor pressure of pure solvent, and in the denominator along with wa, mass of solvent, you need to take p naught a minus pa. So this is a final formula we can use to calculate molar mass of solute according to relative lowering of vapor pressure, where mb is molar mass of solute, wb is mass of solute, wa is mass of solvent, p naught a is a vapor pressure of pure solvent, and pa is a vapor pressure of solution. Let us solve one question here. Consider the vapor pressure of pure benzene. Benzene here is a solvent, is 0.850 bar. So this is P naught A. A non-volatile solid weighing 0.5 gram. So here non-volatile solid weighing 0.5 gram. 0.5 gram is the mass of solute WB. 0.5 gram is WB, mass of non-volatile solute. When added to 39 grams of benzene, so here benzene mass is 39 gram, so that is 39 gram is wa, mass of solvent wa. Higher value, higher mass is of mass of solvent, and lower is the mass of solute. And molar mass of benzene is given 78 grams per mole. This is per mole, 78 grams per mole. So molar mass of benzene ma is 78 grams per mole. So after dissolving 0.5 grams of non-volatile solid, vapor pressure of solution is decreased to 0.845. This is 0.845 bar. 0.845 bar. This is Pa. What is the molar mass of solid? We need to find out molar mass of solid mb. mb is question mark. So we know the formula, molar mass of solute mb is equal to wb, mass of solute, ma, molar mass of solvent, p naught a, vapor pressure of pure solvent, mb this is mass of solvent wa. So when we substitute, mass of solute is 0.5 gram, molar mass of solvent 78 grams, vapor pressure of pure solvent 0.850, mass of benzene, mass of solvent 39 gram, then P naught A 0.850 and Pa 0.845. When we calculate, we'll get the molar mass of solute, non-volatile solute 170 grams per mole.